The development of low Earth orbit tourism and lunar exploration necessitates the availability of advanced and reliable rocket technology. In response, numerous companies have entered the rocket manufacturing industry with a focus on reducing the size and cost of these vehicles. As more corporations plan to launch their own satellites, the demand for cost-effective and efficient rockets will increase. This shift away from the traditional monopoly held by NASA and towards a competitive market of national-level rocket manufacturing companies will increase accessibility and affordability in the realm of space travel. A prominent example of such companies is Rocket Lab in New Zealand, which specializes in the production of small-scale, reusable rockets capable of carrying a payload of up to 800 kilograms. With regular launches and a commitment to innovation, Rocket Lab has established itself as a significant player in the industry. Relativity Space is a rocket manufacturing company that leverages the use of autonomous machines to minimize labor costs, which account for 80 to 90% of total production expenses. The company utilizes 3D printing technology to fabricate rocket components, which are then assembled. Currently, the majority of the components are produced autonomously, though not all. In the future, the goal is to achieve full autonomy in production. The issue at hand is whether rockets will continue to rely on fuel, given their significant dependence on it. The lightweight design of rockets results in a compact size when fuel tanks are removed. Spin Launch is exploring ways to minimize the reliance on fuel by maximizing the rocket's kinetic energy during its launching. The company employs a rocket catapult to achieve high speeds during launch, propelling the rocket into the upper atmosphere where fuel consumption begins. Beyond the rocket industry, there is significant interest in utilizing microgravity for future technological advancements. The lack of gravity in space provides unique opportunities to create items that cannot be made on Earth due to the constraints of gravity. TechShot, a company specializing in the manufacture of human artificial organs, aims to produce these organs in space in the future. To date, the company has utilized 3D printing technology to fabricate various body parts, including the nose and ear. In 2019, TechShot sent its first 3D printer to space to print tissue samples. The microgravity environment enables the creation of complex tissue designs, such as vascular tissues, which can be challenging to produce on Earth due to gravity. Why is it challenging to make these tissues in gravity? Let's understand it from this example. When liquid water is poured in any container on Earth, it takes on the shape of the container. However, in the microgravity environment of space, the liquid assumes its own shape and retains its own distinct form. Even the colors added to water in space do not intermingle and keep their structure. This characteristic of limited forces and non-intermingling objects makes the creation of tissues and organs easier in space. Zeblan, a manufacturer of fiber optic cables, is producing these cables in space due to the difficulties of production in a gravitational environment. The cables will be tested in space before undergoing further testing on Earth. The ultimate goal is to move towards mass production in space. In the future, industries will be established in space, utilizing raw materials sourced from Earth to produce finished goods for consumption on Earth. The International Space Station has already been involved in low-volume manufacturing and is slated to be retired in 2028. At that time, its thrusters will be disabled and it will gradually start traveling towards the Earth's orbit. As soon as it enters the orbits, it will catch fire due to fraction and will be burned in the upper atmosphere of the Earth. A new space station called Axiom is currently in the works. This new station is being constructed by commercial companies and is expected to have a lower manufacturing and operational cost compared to the International Space Station. Its launch is anticipated by 2025, and commercial companies have plans to utilize it for tourism purposes with a 20-day trip, costing $55 million at present. Axiom Space Station, slated for launch in 2025, will feature both an R&D center and a small university, providing opportunities for research and development, as well as conducting experiments that require microgravity conditions. The station will also include a manufacturing department and serve as a training facility for aspiring astronauts. SpaceX has launched a fleet of small satellites with the aim of delivering high-speed internet to consumers. The company has successfully deployed hundreds of satellites into orbit, with plans to launch hundreds more in the coming years. These satellites not only offer faster internet speeds compared to fiber optic, but also serve important functions such as weather forecasting, remote sensing, and agriculture. An investment of $10 billion has been made in this project, with projections for annual earnings of $30 to $40 billion. The potential for profits in the space mining industry is expected to reach trillions of dollars. This highlights the vast potential and opportunities offered by the space industry.